Hello, you're welcome to our lecture series on soil science and ecology. Earlier, we had looked at the soil structures, and in today's video, we're going to look at the soil consistence. The soil consistence. It's a physical property of soil. We had earlier enumerated that the physical properties of soil include horizontation, texture, structure, color, consistence, resistivity, porosity, and temperature. So I want to look at soil consistence. What is soil consistence? Soil consistence basically refers to the ability of soil to stick together and resist fragmentation. That's one definition of soil consistence, the ability of a soil to stick together and resist fragmentation. It can also be described as the resistance of soil to pressure at various moisture contents. That's when the behavior of soil or how a soil is able to stick together at various moisture contents when wet. That's when the soil is wet, when it's moist, and when it's dry. If you press it within your finger and the thumb, the ability of these soil particles to resist the pressure exerted on them basically refers to soil consistence. For instance, it's also describe the structure or the way soil reacts, or sorry, the way soil is when it is wet, moist, or dry. For instance, a clay soil will be sticky after the rain. When it rains, and sometimes you walk on the clay soil, you actually notice that it sticks to your shoes, to the sole of your shoes. And every clay soil you definitely see that it's consistent. If the soil becomes dry, it becomes plastic. The soil becomes plastic, and when it dries up completely, the soil becomes hard. So clay soils, shortly after the rain, are usually very sticky. Then when they become dry a little bit, they become plastic. You can mold them into any shape, and then when it becomes dry, they become hard. That's the behavior or how a soil is able to resist pressure at various moisture content, and it refers to as it's called the consistent or soil consistent. Soil consistent and its description depends on soil moisture content. Consistency is measured at three moisture conditions: air dry, moist, and wet. The measures of consistency border on subject as they employ the feel of the soil in those states. Now, soil consistence, the terms that are commonly used to describe soil consistent are: one, sticky, plastic, that's two; three, loose; then four, friable; five, firm; six, soft; then seven, hard. Now, when the soil is wet, it can either be sticky or plastic. Then when it is moist, it could be loose or friable or firm. And when the soil is dry, it would be soft or hard, depending on the soil type. So I want to look at each of these features of soil consistent, each of these terms that I used to describe various types of soils. The first is about wet soil. When the soil is wet, it can either be sticky or plastic. And sticky soils adhere to other materials and tends to stretch somewhat and pull apart rather than to pull free from other material. And clay soils are known for that. When they stick to a surface, it's hard to pull them off. It's either they break off or pull, rather than pull off from the surface they have been attached to. So such a soil is said to be sticky, and it's common to clay soils. Then the next terminology in soil consistent is plastic. For soil to be plastic, it means that when it's wet, it's readily deformed by moderate pressure, but can be pressed into a lump. Then it will form wire when rolls between thumb and finger. So the soil becomes plastic, it becomes malleable, it can be molded into various shapes. And such a soil that can easily be molded into various shapes. A typical example is the clay soil. Such a soil is said to be plastic. Now, when the soil is moist, the soil can either be loose, friable, or friable, or firm. Now, a soil is said to be loose when it is non-coherent when dry or moist, and it does not hold together in a mass. And typically, this occurs in a sandy soil. A soil is said to be friable in that when it's moist, it's crushed easily under gentle pressure between thumb and forefinger and can be pressed together into a lump and easily reduced to tiny particles. And this occurs in sandy loam, sandy clay loam, and silt loam soils. Then a soil can be said to be firm in that when it's moist, it's crushed under moderate pressure between thumb and forefinger, but resistance is distinctly noticeable. And is found in silty clay soils and silty clay loam soils. Then in dry conditions, when the soil is dry, it can either be soft or hard. Now, soft soils in dry conditions are usually sandy soils, and they break into powder or individual grains under very slight pressure. The sandy soils, when dry, are said to be soft because they are easily broken into individual grains under very slight pressure. Then the soil is said to be hard in that when it's wet, is moderately resistant to pressure and can be broken with difficulty between thumb and forefinger. So it's found in such soils are usually clay soils or silty soils. Such soils are usually either clay soils or silty soils. Soil consistence is useful in estimating the ability of soils to support buildings and roads. More precise measures of soil strength are often made prior to construction. So thanks a lot for listening to this aspect of the course. We want to look at bulk density. Now, what's bulk density? Bulk density basically refers to the proportion of the weight of a soil relative to its volume. The proportion of the weight of a soil relative to its volume. So the weight of the soil is referred to as the bulk density. It is expressed as a unit of weight per volume and is commonly measured in units of grams per cubic centimeters. Now, the bulk density of any particular soil sample is affected by the pore spaces within the soil particles. So the pore spaces, to calculate the bulk density, you use the following formula. Pore space is equal to 1 minus bulk density divided by particle density. An increase in one variable by a given factor brings about a decrease by the same factor in the other variable. So we have looked at the fact that bulk density refers to the proportion of the weight of soil relative to its volume. And now it's known that the larger the soil particle, the smaller the bulk density, the lower the bulk density, because of the pore spaces between the particles. Because of the pore spaces between the particles. So it is known that sandy soils tend to have higher and lower bulk density than clay soils, because clay soils have much smaller pore spaces, and that enables them to accommodate more particles and makes the soil particles to be heavier. So we will now look at other physical properties of soil in subsequent videos. Thanks for watching this video. Please subscribe to our YouTube channel for more updates.